Thank you very much, and good afternoon to everyone, and welcome to the Galaxy Workshop. Just let me do my Zoom normalities of screen sharing. Afternoon onto the Discord server. Some of these you will need for the workshop, so please do have that up. I know we've been asked to use Zoom sparingly. If you can't access the Discord, we will post those same Zoom links into Zoom, so please do ask. Or if you're familiar with the Zoom chat function and participant function, feel free to raise your hand at any point if you would like us to comment on something. So we'll get started. So welcome, my name is Gareth Price. I have two roles. I work in Queensland in Australia at the Queensland Centre for Queensland Cyber Infrastructure Foundation Facility for Advanced Bioinformatics, which thankfully shortens all the way down to QFAB, where my role is to interact with academics all around the state of Queensland and Australia to support bioinformatics projects that they bring to us. The other half of the time, I spend my time as service manager of Galaxy Australia, a service we're very, very proud of that's grown phenomenally over the last few years in Australia. And today I will be co-presenting with my co-driver of Galaxy Australia, Simon Gladman.
Hi everybody, my name's Simon Gladman, and I am a senior bioinformatician at Melbourne Bioinformatics at the University of Melbourne in Australia, and I'm also the lead engineer for Galaxy Australia. And it's my job to make sure that Galaxy is working and work on all the improvements and work closely with Gareth to make sure that we provide a nice service to everybody. So, yep, that's me. Back to you, Gareth.
Thank you, Simon. Simon and I will be toggling back and forth between the screens. And so, yes, but anyway, do keep interrupting. So the last piece of context I wanted to give was two contexts, one for why we're at InCoB and two, why we've chosen to provide this particular content this afternoon. So one of the things that our funding bodies, the Australian Biocommons, which is the main one in Australia, is very keen on is globalization of e-research. And part of what you're going to hear today is about the globalization of the Galaxy platform and how that actually makes all our jobs easier by sharing load and sharing knowledge on a global basis. To that end, one of our favorite global colleagues, Dave Clements from Galaxy Project in America, arranged and cajoled and coerced and encouraged us last year to join InCoB2020 in Jakarta, where Simon and I flew over with our colleague Nguyen. Really enjoyed the conference and welcomed the opportunity to present Galaxy there. And it's all about part of growing Galaxy globally. I will send apologies on behalf of Dave. At this point in time, it is Thanksgiving in America, a very important time for him and his family. Since Simon and I are both from Australia and we don't celebrate Thanksgiving, it's been much easier for us to drive this workshop this year. So the idea this afternoon over the next few hours is two parts. We want to tell you everything about Galaxy, and we also want to involve you in some workshop elements of actually doing in Galaxy. And as the title suggests, this is a platform for life science. It really can be a platform for anything. Its history and its basis is in the life sciences. And by the nature of the economics of data production, the major data producer for the last few years has been genomics. And really what we want to give you this afternoon is an impression that yes, Galaxy is a great platform for genomics, but that it has grown beyond that, and that if you have life science-based data beyond genomics, you should absolutely consider Galaxy to be one of the destinations and one of the platforms to utilize for our tagline, which is reproducible open science. So with all that, I will get started. Simon and I are going to talk back through a series of slides before we enter into a workshop phase. And I'm just going to do the Zoom paranoid thing. I presume everyone can see my slides with workshop agenda around them. Cool, thank you, Simon. So we're going to spend about an hour talking, both of us, introducing you to the Galaxy platform and code base, introducing you to some of that globalization efforts that are in place for Galaxy. We'll spend the next hour up until the half-an-hour break going through features of Galaxy, but features which are not anchored in genomics. They're some, in many cases, newer features or more advanced features of the service that will really showcase to you what you can do on the platform. There is the scheduled half-an-hour break, and in the last hour and a half, we will go through a few more analyses with you, some examples of some of the fascinating galaxies that exist to do complex data analysis and sort of domain-specific data analysis as listed there. And we thought we would open it up for a Q&A at the end. That doesn't mean you can't ask questions now on Discord, or as I say, raise your hand in the Zoom chat. But if you've got a more in-depth question, please capture it and be ready as the afternoon ends up to give us that question at the end of the day. So I've got a few more slides. If you're not aware, and I hope you are slightly aware of what is Galaxy, I'm hoping you'll leave with much larger knowledge. So Galaxy is a hosted, web-accessible platform that lets you conduct accessible, reproducible, and transparent computational biology research. What that actually means is best shown by demonstration, and we will do that shortly. Importantly, it's free to use. So this applies to those public Galaxy servers that are free. Obviously, if an institute decides to make it costing, that's their choice. But the public Galaxy servers are free to use. It contains over 7,000 installable tools and hundreds of reference data sets. And both of those that we're going to drill into. But at this point in time, I'll really say that a reference data set, and particularly in the theme of this afternoon, is not necessarily just a reference genome. It's any piece of data that you as a user want to access regularly and reference your data to. We can host those. If we host them, they're much more efficient than you maintaining them in your subsection of Galaxy. In terms of allowing you to do reproducible science and transparent science, Galaxy excels at chaining tools together. The language we use here is workflows. That should be a fairly common language to people in the e-research space. You chain your tools together in a workflow, allowing you to do one job at a time, 100 jobs at a time, 100 tools chained together for one workflow or hundreds of workflows. And again, they're auditable, reproducible, and shareable. One of the things that's really come along in the last few years is Galaxy has grown a very extensive online training material website, and we'll show that, and we will actually use that this afternoon. And it's really hard to undersell that part of Galaxy. It allows us and you to self-discover just shy of 200 training topics worth of content to do self-learning or to do guided training, and we'll talk all about that. So if you take nothing else out of today, please log on to any public Galaxy you can find and just start using it to discover the wonders of the service. Simon is going to speak more in detail about this, but we are also extremely proud, and probably need to give some more context to this, that the Galaxy Australia service we operate nationally and for all our global partners is part of a collective of international galaxies known as the usegalaxy Dostar collective. And at this point in time, that's all I'll say about that till Simon talks to it shortly. So I have already just mentioned, but I want to go into a little further, the Galaxy Training Network. Pardon me, I'm just checking our chats. Yes, thank you. I think we're all good. So the Galaxy Training Network can be found at this first web link, which we'll shortly post into Discord, which is training@galaxyproject.org training material. I did a head count of tutorials whilst preparing these slides alongside Simon, and currently there are 193 tutorials. And this number grows. The topics are listed there. And I think what's important again to focus on in terms of this meeting is that you can see already topics like ecology, imaging, metabolomics, proteomics are all on the list. There's a machine learning one in there as well, statistics and machine learning. And this really highlights that growing base of topics that are outside the genomic space. And also down the bottom of the list there, for those with a bit of an eagle eye, you'll see there's Galaxy Service Administration, Development, contributing to the GTN, which is the training network. So not only are we providing training content globally on biological topics, we're also providing training content on how to get the most out of your Galaxy or how to run a Galaxy. The next global effort maintained at Penn State Uni in America, one of the homes of Galaxy Project, is the Galaxy Toolshed. And you know, the Toolshed, I think, speaks to its older name, now maybe more appropriately known as an app store. But the Toolshed, as of last count by myself, which was listed on their website at October the 31st, 2020, there are 7,923 different tools that can be installed on a Galaxy service. You will find that I think I can boldly say no Galaxy service has all 7,923 tools installed on it. Most of us operate somewhere in the order of 1,000 to 2,000 tools. Some of them are old, some of them are new, but there's a good cohort of them, and this speaks to the Galaxy community once again, that have been audited and sanctioned by the Galaxy community for being stable, robust, full of the appropriate test data, full of high levels of documentation. However, the take home from here today is that if you're on a Galaxy service and there's a tool that's, let's say, missing in your workflow, something that you'd really very much like to do, please do go to the Galaxy Toolshed and explore the tools there to see if there is a tool already existing to do what you want. You can then request your local Galaxy admin to put that tool on. So we do have some questions, and that's great. I'm just going to pause for a sec because it's always fun to answer a question. This one comes from Hilia. What are the differences between one Galaxy service to another? For example, Galaxy Europe, Galaxy Australia, Galaxy America, and so on. I think I might let Simon answer that one in the next couple of slides when he does usegalaxy.star, but that's an excellent question and well worth a few minutes of time. I do promise that we will actually look at the Galaxy interface live shortly. However, I have taken a screen grab from Galaxy Australia, which is the service we quite proudly operate. And really all I want to show here, and it'll be shown again on the next slide, is that the left-hand side of your Galaxy instance is your tool window. This is searchable and discoverable for, at least on Australia, over 1,000 tools, about 1,200 at the moment. Your right-hand side in the Galaxy language is a history, and a history is just that. It's a history of what you have done to the data, how you've analyzed it. You as a Galaxy user can have one or many histories, and I tend to think of them like electronic lab books, each one associated with a different experiment or a different testing modality on the same data. And we'll go into some of the complexities of histories throughout the afternoon. The middle window here is interactive. It can either be the landing page when you land at any website. It will be the tool form for configuring the tool and data, or the tool result, or your workflow menu, or the shared data, or anything else that's interactive in your Galaxy session. So that's it for my first little bit of talking. I will paste some of those links I've just shown into the Discord channel, and I will let Simon take over for a bit.
Unmute. There we go. Thank you, Gareth. I'm going to talk a little bit about usegalaxy.star and the differences, or actually the collaboration between different groups that run Galaxy servers around the world. So usegalaxy.star is actually a collaboration between all the different communities that run large public Galaxy servers around the globe. And it was started around about 3 or 4 years ago, when we all realized that actually we're all trying to achieve the same thing. We're trying to make bioinformatics analysis or life sciences analysis publicly available to anyone who wants to do it. And we figured the best way to do that would be to collaborate and help one another do that. So we decided that we would try and align on a basic set of tools that we would all have installed on our different Galaxy servers spread out around the world. And we would all support a common set of reference data, and that we would have basic workflows available. And our goals are to mainly to provide a similar user experience. So if you go to Galaxy Main in the US and you log in there, then you should be able to see pretty much the same tools and the same reference data that you would see if you logged into Galaxy Europe or into my server, Galaxy Australia. And the other goal that we had was we wanted to make everything reproducible across the servers. So it didn't matter where you did your analysis, the result would be the same. And we can do that by making sure that we have the same versions of the tools installed, the same versions of the reference data, and similar compute backends. So that's pretty much what usegalaxy.star is. It's a collaboration of different communities who run public Galaxy servers. Okay, so at the in the beginning, it was just Galaxy Europe and Galaxy Australia and Galaxy Main. However, this is now starting to grow, and we're expanding, and we're starting to see some new servers and new communities coming online. The Galaxy community in India are starting to build their own Galaxy server, and they're coming up to speed with it, and pretty soon they're going to join in with the, or we hope they will, hope they're going to join in with the usegalaxy.star collaboration, and we'll all start sharing common ideas and things between each other. Galaxy France and some other European servers are starting to pop up, and Galaxy Africa or Galaxy South Africa is also being worked on currently. And so what we hope to achieve with this is to have a network of Galaxy servers spaced out around the world that anybody, anywhere can log into and do life sciences computation. So it doesn't matter where you're from, doesn't matter which institute you work for, or whether you're a private citizen or whatever, you should just be able to log into any of these services and do bioinformatics analysis. And the whole idea is that we want to make it free and accessible to everybody, and that can only benefit science. So at the moment, the way we kind of do these things, or the way we've decided to collaborate initially, is that we've decided that we would make it really simple to share reference data. As you know, when you do life science analysis, you need quite a lot of reference data. And so we've set up a global network of servers that talk to one another, that all share out the reference data, say the human genome, plus all of its annotations, plus all of the indexes that all of the different tools use to use that data. And so we might have, I think there's 250 different eukaryotic genomes in our system at the moment, and whole lot of microbial genomes. And all of that is shared via a really cool system called the CERN Virtual Managed File System, which we don't really have time to go into today, but basically it just means that we have one source and then everybody else in the world gets to share it very, very easily. We're also starting to do the same thing with singularity containers for all of the tools. So every time a tool has a conda recipe built for it, so a dependency map, I guess you could call it. Part of the conda system is that it will also make a singularity container of it, and we also mirror those all around the world, so we can hook them into our Galaxy servers to make life a lot simpler. So that's kind of what we're trying to do with usegalaxy.star. We just want to make it very simple for communities to supply a Galaxy server to their local area or to the public at large. Okay, so I'm going to talk a little bit about how we've decided to deploy Galaxy in Australia. Australia is quite large and quite diverse. There really isn't anyone living in the middle here. Everybody kind of lives down here and over here. And so one of the problems we have is that we have a community that's spread out. This is about 3,000 kilometres, I think, about 3,000 kilometres from Perth over here to Brisbane over here. And that's quite a long way. And we also have limited budgets, etc., to supply this service. And so what we've done is we've decided to distribute the computation for Galaxy Australia around our country. And so when you log on to the Galaxy web server, you land at a computer in Brisbane. But when you decide you want to do some analysis and Galaxy says, I want to run a job, you have no idea where the compute's done. It could be done down here in Melbourne, or it could be done over here in Perth. It could be done in lots of different places. And this is all transparent to the user. And quite frankly, it doesn't really matter. As long as your analysis gets done, it doesn't really matter where it gets computed. And the idea is that this way we can balance the load for all of this computation out amongst lots of different institutions. And we're beginning to bring on some HPC resources and some high memory resources. And the idea is that if any other institution wants to join in on our network, they can supply a little bit of compute, we can add it into our network, and then they get access to all of the rest of it. So our central web server is in Brisbane, as I said. Compute is distributed all the way across the country. Galaxy itself decides where jobs best fit and sends them there. We have a continually growing set of tools and reference data. We're updating it all the time, and all the tools are automatically updated. So every week we run a script that goes through, checks all the tools to see if there's a new version of it, and then goes and installs the updates. It's actually pretty cool. All right, and now back to Gareth.
Thank you, Simon. We did have a couple of questions posted in the Zoom chat that I thought it might be useful to go through and just get both our opinions on, actually. They're just a bit further up the chat. So you've already answered, thank you, Simon. What's the difference between the Galaxy servers? We have one from Rubina Deep. Can we use any Galaxy server or specific to our community? The servers that Simon has just described, Galaxy Europe, Galaxy Main and Galaxy Australia, and the oncoming other used Galaxy services have firmly committed, and certainly in Australia from our funding bodies onwards, to be an open science global platform. So in lieu of not having your own national service, and I'll explain why that might matter, yes, please do go use those global Galaxy servers. That is what they are there for.
Yeah, indeed, we have users from all over the world that use Galaxy Australia. People in Brazil, Peru, Indonesia, Malaysia, Vietnam, China, Japan, all over the place, and America and Europe and Africa, everywhere. Yep.
And that is absolutely true. The consideration any of you need to make or think about if you're going to go back to your institutes and pitch for a Galaxy service or use of Galaxy is data sovereignty. So what we can proudly say in Australia, but it also applies to the other services, is that all the computational and storage resources for Galaxy Australia are maintained jurisdictionally on Australian land. So this does help us. It sounds selfish, but it helps our researchers conform to their ethics requirements for some granting bodies, and it also helps to conform to granting applications where there may be data privacy concerns about sharing on cloud resources that are ill-described or completely globalized, like Amazon and Google. So if you do have that concern, you do need to bear that in mind in your use of Galaxy, although I would say that that is a very minor consideration in the global scheme of things. And Hillier, oh, sorry, Simon, go for it.
So for the next question, someone asked, is one server more complete than others? So the 3 big public servers, and plus all the other ones that are coming on board now, do actually run slightly different tool sets. So Galaxy Europe has around about 2,300 tools installed. Galaxy Australia has about 1,500 tools, and Galaxy Main over in the US has about 1,500 tools installed as well. And then other public Galaxies, there's about 127 or so public Galaxies around the place. They will all support different tool sets depending on what what community they're trying to target. But the 3 usegalaxy.star servers so far are the ones that probably have the most complete tool sets. But they do slightly vary. Europe are happy to install everything, where we like to install things slowly so we can test them so that we can test them and also maintain our support for them. So yeah, hope that answers that question.
It does for me. Thank you, Simon. So just as a reminder to everyone, a slide like this, which I'm about to talk to, I have just posted all these links into the Discord channel as well for people to follow along and use. So I rather tongue-in-cheek, I believe, paraphrased an American speech here, a platform for the people, by the people. But this is really to emphasize that Galaxy exists and has succeeded by virtue of engaging a global community of people. So it's not the first GUI interface for doing life science research. It will not be the last. It has parallels in commercial products, but it really has reached a fascinating global momentum by virtue of the extent of its use globally. So if you're intrigued, and Simon's already hinted at this, by last count by me, there's 127 public Galaxy servers, and they can be found at the galaxyproject.org/use. And there is a brief description for the subdomain of what of each of those servers services. Earlier this year, Galaxy Project proudly announced they had surpassed the 10,000th publication citing the use of a Galaxy server. So this is tracked, and this is obviously wonderful for us as providers of a service, but really that's not what it's about. It's about actually showing that there's an awful large amount of research that occurs globally that relies on Galaxy to help produce peer-reviewed and peer-accepted novel research. So that was a phenomenal milestone to pass. The Galaxy Project does maintain a Vimeo account with screencasts. They do have the community hub, which is pretty much the landing page for everything, galaxyproject.org. They regularly tweet at Galaxy Project via that Twitter account listed there. And there is also a Gitter channel, which can be a great place to go to ask questions specific to running a Galaxy service, a tool, an observation, etc. So across all those mechanisms, the community is quite active and vibrant. One of those parts of the community...
Sorry, Gareth, just before you move on, there's also a really good help forum at help.galaxyproject.org.
That's true. If you could post that into Discord, Simon, and we'll update the slides. So I have just been discussing offline that we will make the slides available either by Discord or by sharing at the end of this workshop, so that you do get all these links as well. Now, we have talked about training a few times already in the start of this session, and this is something that was championed out of Galaxy Europe and is very, very successful there. Simon and I will be meeting with some of our national compute partners next week to see if we can spin this service up in Australia. And I know Galaxy Main are also actively considering this service. And the service I'm talking about is called TIAS, which is a very nice, short, easy to say name, which is actually training infrastructure as a service. And the idea behind this is best exemplified in the question on the graphic on the right-hand side. that on any given day, every Galaxy has multiple users coming to it with simple or computationally intensive demands. And it's our job, and in our case, mostly Simon's job, to balance that load across all the resources we have in Australia so that they run optimally for all the users. However, we have a particular cohort of users globally, and you participants here today will be considering this as well. If I'm doing a workshop and I have a constrained amount of time, can I get priority access to computational resources in a way that allows me to get through my workshop as effortlessly as possible? And that is a TIAS service. So a TIAS service gives you a private queue into dedicated computational resources. Again, it's free. All the Galaxy Training Network materials work on a TIAS service and are regularly tested and updated. And through the use of two different styles of dashboard, you can have an insight into where all your participants are up to. So as shown here, you have a state overview, the number of participants that are sitting in an OK state, or the number of jobs, sorry, that they have completed sitting in an OK state, which is a analyzed or uploaded state. The number that are running, the number that are in error. Pardon me, my Zoom box has popped up. And then an overview specifically by the tool, so that you can actually come in and focus and say, why do we have a particular tool that is erroring? Is this slowing down students? And of course, in light of how we're all presenting at conferences at the moment by means of virtual conference, this is an extremely powerful tool to keep an eye on where all your participants are up to and help modulate the flow and intensity of a workshop based on tracking their activities. You can also do it specifically by user ID. So you can see the user ID in this rainbowed color code down the left-hand side of the screen, the tool that they're most recently up to, and the status that tool is in. If you're an administrator on the service, you do get a job runner ID, so you can look that up to check that it's going to run okay. Specifically, again, this is about helping troubleshooting students that might be stalled. And the user ID, just of note on the left-hand side, is inspired by the European Union's privacy laws. So it's a hexadecimal code for the user. It's color-coded. You won't necessarily know who that user is, and that's by design so that there's no privacy concerns as you're going on. So a little bit more on community and a little bit of an upsell for what 2021 is going to bring for all of us. So the Galaxy community really does benefit from its community nature and getting together. And the two events that I wanted to highlight here today, one because the application is closing soon, is the Galaxy Administrator Training course that will be held from the 25th to the 29th of January next year. It is online, it's global, and it is free. However, it does have a cap on the number of attendees. So please, if you would like to find out more about how to run a Galaxy service, then please do apply by December the 18th. You can find all the information for that on the galaxyproject.org website. I'll let Simon say a little bit more about that if he wants to in a minute, because I know he is presenting there. I will also just very quickly, however, talk up the next Galaxy Community Conference. So in 2020, we chose to have the community conference held virtually in parallel to the Bioinformatics Open Source Conference. It was originally scheduled for Toronto in July. It would have been a great event to go to Toronto too, but we are glass half full and we are planning and excited about journeying to Belgium next year, if we can, to join the Galaxy Community Conference there. Simon, did you want to say anything about either of these events? Because I know you've been a long-term attendee or presenter at both.
Yes, so there's a couple of things. The first one is about the Galaxy Community Conference. I personally found the Galaxy community to be the most welcoming and friendly group of scientists I've ever been a part of. So the first conference I ever went to, I'd only been using Galaxy for about a year, and I didn't really know anybody in the community. I didn't really know anything. I went to the conference and I was immediately made to feel welcome. And they usually get 200 to 300 participants at this conference, and it's seriously an absolutely wonderful experience. And I've made some really, really good friends and contacts, and we've shared a lot of information backwards and forwards since. So yeah, if you do get a chance to go to a Galaxy community conference, even if it's a local Galaxy community conference, the people in the Galaxy team and everyone in the Galaxy community just seem to be very, very friendly and very open and easy to get along with. So, and then the second one is the Galaxy admin training. So if you're thinking about you're interested in Galaxy and you would like to run a Galaxy server, say for your lab or for your institution, then it's quite simple to do, and there's a lot of training material on the training website about how to go about doing it. But we will be running a full Galaxy admin training course about setting a Galaxy server up and how to administer it on the 25th to the 29th of January. And I'll actually be helping to teach part of that course. So yeah.
Thank you, Simon. Yeah, since my first one was last year, I can echo all that certainly. So, and again, in the theme of the afternoon that I keep wanting to return to, which is that, yeah, Galaxy is a great platform for genomics, but it's more than that. I was absolutely fascinated by some of the poster content at the last year's Galaxy Community Conference to see people using Galaxy for ecology, which we'll highlight later, Galaxy for linguistics, Galaxy for imaging processing. So really, it is a place to also learn where you can make the most use of the platform for other areas of research. Okay, so we have, well, to be honest, quite a bit more talking to do. I do promise an activity is coming up soon, and I think by the timing, we are actually doing fairly well for our timing for the afternoon now. So I wanted to come after talking about the community to talk really about the next most exciting part of the community. I can see on the Zoom chat, we've had some great questions in the latest one about, you know, how do I add a tool to a Galaxy service? And thank you, Simon, for answering. And adding a tool to the service grows the tool for you as a user, but our experience has been that it also grows the entire Galaxy experience for the rest of the research community. It is rare that a tool request comes from one researcher for their sole project alone that they will use once and never again. The addition of a tool to a service tends to enrich that Galaxy service for other people that come to use it. And the next way that the Galaxy code base is enriched each year is through tri-yearly updates to the service. So from the GitHub Galaxy project site, one can get in and see all the pull requests and issue requests that are associated to the code base. You can see that there are currently listed 251 contributors to the Galaxy code base, and again, that's a global contribution, not centered in any one country. And Galaxy aims to release 3 updates a year. If you're new to the language around Galaxy, the updates are listed as year, and month. The latest update being September, so it's 20.09. The previous one was May, so 20.05, etc. The 20.09 update contains 174 enhancements, mainly driven by user request to the service, and 176 fixes, and again, comes in through observation and user highlights. There are both user level documentation and developer and admin level documentation for how to get in and see what the latest 20.09 updates are. However, I thought given that this released this week, that the workshop here at InCoB today would be an excellent opportunity to bring you up to speed on some of the latest Galaxy improvements. So we have a few that have been picked out, and they've been picked out by Galaxy Project, but echoed here. So just in brief, if you've not used Galaxy before, you might be curious to how we're going to bring data in, and I'm going to show one of the ways to bring data in shortly. If you've used Galaxy before, you'll know that the traditional mechanism to bring data into the service is through your own local computer. And in many ways, this is completely tolerable, and certainly was tolerable 2 to 5 years ago, where the volume of data you had coming off a life science data production machine, anyone, a genomics or proteomics, was not relatively huge, and you could tolerate uploads through your own computer. But increasingly so, we're seeing people bring larger and larger data sets to Galaxy. And in Australia, we have recently linked up our national cloud compute, known as Cloud Store, to Galaxy. So now users of Galaxy Australia who are an Australian researcher, they're all given 1 terabyte of free cloud storage. They can now bring data in and out of their Galaxy service to their personalized cloud store. The Galaxy project in 2009 has released this as the ability to upload from Dropbox and any other cloud-based WebDAV supported storage locations. I've talked a lot to this, but effectively the new version of 2009 has choose local files, has paste and fetch for public URLs, and we're expecting some version of button to have Dropbox enabled import into your service, and we're actually really quite excited about that. We are using the Galaxy Training Network today, and we're going to be using Galaxy Europe, which has championed the features of this video we are showing here at the moment. The video has just highlighted in its first few seconds this small academic hat icon that will be visible in Galaxy Europe. When you click on this, you enable the training material as a pop-up into the screen. This is already fantastic for those that are working on one screen or maybe have less real estate in their computer, because you can now navigate to this tutorial without having to have multiple windows open or multiple screens on your computer. The next bit of it, which may have just been obvious or not as I was talking then, I've just gone past it, sorry, is you can actually copy directly out of that pop-up and back into your Galaxy service. So it's an interactive window, it's not a static window. And the final part we're super excited about, which is the click to run service. So if a tool is available in the GTN content, you should be able to click on that tool if it's highlighted in that blue functionality that was shown there, and the tool will pop up inside your Galaxy instance, which means we've really much more seamlessly integrated the training material into running your Galaxy instance. Another one, and this one's not supposed to sound embarrassing, but it's actually extremely frustrating sometimes, is when you're partway through running a tool or a workflow and you forget a piece of data. If you've forgotten that piece of data, you can now actually activate a tool upload directly from, a data upload directly inside the tool form, which means you won't have to escape out of your tool menu, bring data in, move around again. Some of these features sometimes, and I don't mean to be any way rude to the code base writers of these, they look like small features, but they're actually fantastically powerful additions to the service because they make the user experience so much more seamless. A couple more which are coming. The next one is the workflow layout. So again, observationally, we've seen users grow from very small workflows to very, very large workflows, and large workflows can have hundreds of chained tools in them. And the logic of the algorithm that lays these tools out is completely fine. It's left to right, it's columnized, and that's what you're looking at here. And it works absolutely fine. It does, however, lead to some audit trails that can be particularly difficult to see as noodles curve under boxes and across boxes throughout their journey. 2009 will have an enhanced human readable algorithm for lack of a better term, for workflow layout. And this is what we're hoping, what we know workflows will look like in the next version of Galaxy, where really subsections of your workflows are broken out to minimize the number of these lines that are crossing under or over boxes so that you can more readily see the flow through your data. So that's our talking. And I'm very much hoping people are keen now to do an activity alongside us. I will do this activity. I'm going to do this by toggling between my Galaxy screen and the presentation. That's going to be a little difficult for you to follow all of it. So I will describe first of all what we're going to do. And I probably should have said it earlier, but anytime you see one of my slides or Simon's slides with the lovely big purple activity on it, that's the time to get involved. Thank you, Simon. So Simon has just posted into the Discord and Zoom chat that for today, we will be using the European usegalaxy service. And it really does need to be said that we thank them for their generous resourcing of training events and workshops globally. We're doing this because we do have Galaxy Australia. We are just very much in the process. We're only a day or few away from migrating some of our graphical user interface to some of our website to a new infrastructure provider, and we just didn't want to put the service under unnecessary load at this point in time. So I'm very much glad that we've had conversations already in the workshop so far about the various Galaxy services around the world and what it means to be on one or the other. The one thing we haven't covered yet is if you do register on the European Galaxy service, you will be required to re-register on Galaxy Australia or Galaxy Main. They are all independent services. We do not yet, there may be some holistic future where we do, but we do not yet share data or login information across the global Galaxy services. So what you experience on Europe today will be very much what you experience at Galaxy Australia if you choose to come there in the future, but we will be using Galaxy Europe. So what we're going to do, and you're going to watch me do, and I encourage you to follow along on your screens, is we're going to create an account, if you don't already have one, at Galaxy Europe. Log in with that account. We're going to create and rename a history. We're going to then paste in 2 pieces of data. We're going to see what they do as they arrive in Galaxy, how you can annotate and audit your data sets for long-term traceability, and then we're going to run a tool, and the tool we'll be doing is called compute an expression on each row. This is all going to maybe look wonderfully simplistic if you've used Galaxy a lot. If you've never used it before, it will be a great insight into how Galaxies work. I am just picking an appropriate screen. Why not? This one will do. And I'm presuming you are now watching me load a usegalaxy instance. So this is the usegalaxy service in Europe, the usegalaxy.eu, and I am currently logged out of the service. The system looks very much like what we've already been discussing. We have the tool menu on the left-hand side. We have what will be a history of data on the right-hand side and an interactive window in the middle of the screen. There's lots and lots of little things I could show you about Galaxy operations, which are very much cosmetic. I think if people are curious, we can talk about those in the final half an hour, or they will come up naturally. So if you're following along, please do. If you're going to watch me, watch away. But the first thing you're required to do, you can use a Galaxy service and navigate through tools and upload extremely limited amounts of data without logging in, but would always encourage you to log in or register to track all of your data analyses. If you've never come across a Galaxy service before, I'm just going to open up this. No, I'm not in a new window, you'll be required to create an account. An account at this point in time is email address, password, and some form of public name conforming to the criteria that are listed below that box. Most of the Galaxy services also do have a terms and conditions. Australia is about to formalise our ones. So just be aware you may have some terms and conditions. They're generally very benign. So if you haven't registered, please do go ahead and register. So effectively it is email and password. Once you have done that, you'll be able to log in to the service. Now again, if you've already experienced Galaxy, you may well have a history sitting on the right hand of your screen. If you have not currently used Galaxy Europe before, your screen will look as mine does now. The tools on the left-hand side, user as the menu across the top now, and an empty history on the right-hand side. Just of note, all the Galaxy servers do track the amount of data you store, and some of us, like Galaxy Australia, we have an upper data limit. It's a soft limit, so please do ask us if you need more space, but this tells me I'm using a rather humble 11.2 gig out of my allocation, which represents 4% of my total. So I'm in nowhere near close to filling up my Galaxy at Europe at this point in time. So just going back to the talk, we have created an account. The next is we're going to create and rename a history and upload some pasted data. And we're going to do this in two different ways. So the history menu on the right-hand side has a refresh. There's refresh buttons scattered all across the Galaxy service. It has a create new history. It has view all histories. This is a really great way. It will take a minute to load on any Galaxy service. But it shows you all the previous experiments, modalities, explorations you have done on the Galaxy service. I am currently in one called unnamed history. Your history also has a number of actions. We're going to talk to some of these as the afternoon goes on, and they'll become more relevant as you see where Galaxy really becomes that open source platform. Probably the most important thing to do, and if you're, well, I'm a personal advocate of the FAIR principles, which is findable, accessible, interoperable, and reproducible, which is a way of saying I'm a big fan of naming everything logically in your Galaxy service so you can find it again. If you click on unnamed history, you can rename this history to anything you want. If you click away, it will get accepted. That is new. It used to be different. So I'm going to rename this as InCoB Workshop 2020 1127. Please feel free to name yours anything you would like. However, I would encourage you to name it in a way that is relevant to you medium to long term. You can also annotate your history, and that's a great way of adding value, particularly if you've brought that history in from somewhere. So for example, again, I could say InCoB Workshop run by Simon and Gareth. Just to remind me when I next look at this history, why I'm using it. So what we'd like to do now is talk about multiple ways that you can bring data in. We're going to start with some of the easiest and build up to some of the more complex. On the top left-hand side of your screen, in the tool menu, you have Get Data, and there's a lot of options for downloading data from open repositories around the world. We also have Upload from your computer. Upload from your computer will take you to the same pop-up menu as upload files from disk or download from URL. and we'd just probably encourage you to use that little icon. Down the bottom of your screen, you can choose local files. If you do, that will open up to local files on your home computer. The next most popular is paste/fetch data, in which case you can literally paste data into here and it will be loaded as a history object for you, or you can paste in any URL that is publicly available, and we will do both. So for example, in classic computer language, I can type hello world into this box and hit start. When I do, a number of things happen. The status went from adding to history, it went green. If I'm quick enough and close, you'll see this is sitting as a queued item in my Galaxy service. This means that Galaxy has accepted the data, it's processing it into a Galaxy-based format and essentially saving it ready for use in one of the hidden structures that the Galaxy system operates. And there we go. So I now have one item called pasted entry in my Galaxy. I can click on that line item to get a data preview. The data preview is not as extensive as if I click on view data, in which case that middle interactive window will populate with the item. The eye icon is contextually dependent. So if it's something that can't be viewed, you'll be told it can't be viewed. If it's a very large file, it will display only the first megabase of that file. So there are ways to get around it. It tells me it's a one-line file, which is very encouraging because I only added one line of data, and it's a text format. And that's probably all I want to look at right now. So we're going to do a second upload. The second upload, I'm just going to reset my screen to take me back to this blank place. And this one is always a bit of fun to do in workshops. It generally works, but it also teases out some fun things about Galaxy that I'd like to show you. So, actually the question that's just been posted onto Zoom is exactly why we're about to do this exercise. So Kiki, thank you so much for asking this question. And the question is, what kind of a file by its extension is acceptable to be uploaded? I'm going to say humbly, almost every file you could ever think of is acceptable to be uploaded, but thinking in the context of research and science, gzip files, TAR files, non-compressed files are all acceptable to be uploaded. Recently added was a whole heap of sound files for people that are doing acoustic analysis, but the best way to look at that is actually on my screen here with this function called type. So Galaxy will attempt to auto-detect your file type. What the exercise we're about to do, I suspect the auto-detection will fail, but I'm designing it to fail because I want to show you how that works. As an exercise, if you scroll down this list, you'll find quite an extensive list of file types supported by Galaxy. You can bring in any file type. If it's not supported, it simply means Galaxy will host it as a file entry, but may not be able to manipulate it without understanding the file type. So we're going to bring in a file, and I'll repeat this a couple of times for everyone's benefit, but it is 1 space 2 space 3 return, 4 space 5 space 6 return, 7 space 8 space 9. So we've just made a 3-line file of 1, 2, 3, 4, 5, 6, 7, 8, 9, all with an individual space between the numbers. We're doing this because there is a rather esoteric function, but one that's well worth knowing about under the settings upload, called convert spaces to tabs. So if you are ever in doubt about hidden characters in your file, and spaces would be one of the more common hidden characters you're going to experience, we can convert spaces to tab. when this file comes into Galaxy, which I'm about to hit start for, it should be in columns as recognized by tabs. Again, this is now sitting as a pasted entry, waiting to be queued, and then we will view it once it comes into the service. And you can see mine is now being processed, ready for viewing. And it's ready. Pasted entry number 2. And yay, I'm very excited because it has thrown an error. It's thrown an error in a way that hasn't errored. So this box is green, it's not red. It, however, has determined by auto detect that this file is apparently a baird format file. If we view the file below, you'll see that it has been named column 1 as chromosome, column 2 as start, column 3 as end. If I view the file in the middle window, sorry, I'll do that again. I may just need to zoom out to make sure I can see it. No, it's just taking a sec to, there it is. You'll see now that actually it's anticipating this is about a 9 or 10 column file of baird format. And this is one of those scenarios where Galaxy has guessed the file format incorrectly. It has interpreted the first 3 columns to be genomic coordinates and not a simple tabular file. This is part of the reason why we do this exercise, to show you that whilst Galaxy gets it right almost all the time, you do need to know how to check for these things. So we have a file type baird, and what we do also have beside viewing data is we have the ability to edit attributes of the data. You can see already that we have an attribute name. That's fairly obvious from the right-hand side of the screen. We do actually also have some populated information, which is it's an uploaded baird file with no annotation, etc., and different columns to be assigned. We can actually convert this file type from one file type to another, although none of these file types make sense because it thinks that this is a baird file. We can also change the data type. Now, this is extremely powerful thing to do, but also should be used with caution. You shouldn't necessarily need to go and be changing file types without some certainty that you're right and Galaxy is wrong. In this case, we're right and Galaxy is wrong, but that's because we set the exercise up that way. To follow up with a question from Kiki before, yes, there's a huge number of file types we could change this to. Galaxy is great. You can simply search on anything. And I wish to turn this baird file into a tabular file. So I typed TAB and Galaxy started shrinking that menu, and I'm now going to change my data type. When I'm doing this, as it's been nicely saying here, the file isn't being essentially rewritten, although it can be. What we're rewriting is the metadata associated with that file. It never takes too long, but it is also in a queue with everyone else doing work. I'm not deliberately impatient here, but just to highlight, you can always click on the location top left, Galaxy Europe in this case, to refresh your Galaxy instance, and the whole screen will come back to us, back to the landing page, but also it has refreshed our history now. And now I can see that pasted entry number 2 is a tabular file. When I view this file, you can see there are now columns 1, 2, and 3, and data 1, 2, 3, 4, 5, 6, 7, 8, 9. This is very boring. It's a small file, but if you imagine that this file is 500,000 lines long and 50 columns wide, then manipulating this in Excel is tiresome, if not impossible. Manipulating it in Galaxy is extremely easy. Since COVID is something we're all super popular on at the moment, for example, the NHS in England was somewhat embarrassed a few months ago when they realised they were over 12,000 cases behind in reporting, and they were over 12,000 cases behind in reporting because they had reached the row limit in Excel for calculations, and the new cases were simply not being calculated because they had reached the limits of Excel. So part of that is to say, please do consider something like Galaxy for any large file manipulation that you think you might be able to do elsewhere, because you do not have an upper limit here. So the final part of this exercise we're going to do now is search for a tool and compute an expression on our data. If you don't know where your tool is in any Galaxy, you may be faced with scrolling through an awful lot of descriptive style menus looking for your tool. I do hope you have an understanding of the tools you might want. In this case, we do want to do some text manipulation, and what we want to do is compute. C-O-M-P-U-T-E. You can see my Galaxy menu is happily searching away and presents me with an actually large number of options with compute, but still smaller than what I would have gotten had I just gone through. We would like the tool called compute an expression on every row. So if you type compute into the tool menu, you will get compute an expression on every row. And I really do this to just highlight a few things about Galaxy. The way a tool is brought into Galaxy, it is populated with functionality. So here it says the default expression is column 3 minus column 2. You get to choose which piece of data to do this on. And again, back to Kiki's question, data 1, which is a text file, is not an acceptable data type to be computed by this tool. So despite having 2 pieces of data in my Galaxy history, only one of them is available in this tool as it conforms to an appropriate input for the tool. So again, you can bring in almost any file type to Galaxy. If it's available to be computed against is the second question. I'm not going to worry about anything else because I'm talking too much. I'm simply going to execute this tool. Galaxy Europe has some fantastic machine learning algorithm sitting that we're going to apply to Galaxy Australia shortly that tells me that if I choose compute as a tool, here are the most common tools that people do after the compute tool. This is just designed to give you a little bit of inspiration in where you might go with doing a piece of data analysis. My computer's working away. It's finished. I will view it. And now a 4th column has been added to my data set, which is the function of column 3 minus column 2, which in all cases is a value of 1. A fairly underwhelming result, but designed simply to show you how to manipulate a file in Galaxy. So I might jump back to the presentation now and we'll see how we're going. I think given the time zone differences, someone does need to prod me if we're up to break time, but I think we're still a bit further away from it. So yeah, we're good to go, I think. Simon, remind me, we're getting through this one and how much more? Sorry, I'm just looking. 3 more activities, is it? Then 4, yeah, okay.
Yeah, so 3 more activities. So.
And yep, so we're going to go through these a little faster now at the risk of me not talking so much, and apologies for that. What I'd really like to highlight here is how we make use of the Galaxy training network, but also we're not going to necessarily do this whole activity. What I want to show you is that you have multiple options for bringing files into Galaxy. So we are going to be using the rule-based import tutorial, which again, I'll just post into Discord as we're talking. I might let you do that, Simon. It's distracting me, sorry. So the rule-based tutorial inside our Galaxy is discoverable under the Galaxy training materials. I'm going to continue to use my history here. It is under user interface and data manipulation. Rule-based uploader. It tells me that this is a slightly advanced tutorial. However, we're just going to do the first section of it. This is the first time many of you may have interacted with the Galaxy Training Network. So again, always accreditation to the wonderful people that write these materials and an estimation of the amount of time it would take to skip through the entire tutorial. The idea behind this is that your data types are getting more and more complex. You may be able to legitimately bring in data one sample at a time or bring it in en masse from a cloud storage, but wouldn't it be great that when you bring your data in, that metadata associated with those samples arrives at the same time? And that's what the rule-based importer was built for. So if you're following along, there's some preamble to tell you how this works, and then there's a table. The table contains study accession, numbers, a sample accession, an experimental accession, and then a public URL associated with downloading that FASTQ data. I am just going to copy all of these into my memory and bring them into Galaxy. So I have copied these into Galaxy, and I'm going to invoke something called the rule-based uploader. To do that, I can simply just click away from the training network. I'm going to go to my upload, and we spent most of our time when looking at upload. Sorry, just waiting for Galaxy Europe to refresh for me. There we go. If ever in doubt about your Galaxy service, please just refresh the service to see where it is up to. So we have focused previously on bringing data in via the bottom of the system, which is the regular method for bringing in data. We have composite, collection, and rule-based, and I'd like to focus on rule-based. Rule-based, you'll see, we're going to upload data as a data set. We could upload it as a collection, and we're going to load tabular data from either memory, from a pasted table, from your history, or from a remote directory. I have pasted it into memory, so I'm going to paste it into this window here. It looks like a little bit of a mess the way it's wrapped. However, when I build this rule-based menu, you'll see that it's starting to look a little better. So here we are now. We have that data sitting in a table ready to bring into Galaxy. It's like bringing in regular, but you are now doing it essentially in a structured manner for many files at once. Just realized I can't have my Galaxy running on my second window, so just give me a sec. No, that's all right. I know what I'm doing. So what we want to do is use filter, because we cannot tolerate header lines, to remove the first or last rows. We want to remove from the first one row and apply. You now see we've removed that first row. And now we want to bring in data by identifying two things: where the data sits, which is in column D as a URL, and which of the names we would like to have associated with it. We could have the study name, but it's the same for all samples. We are actually going to use the information in column C. So we're going to add or use rules to add or modify column definitions. And the first definition we're going to use is name, and apply that to column C. Then the second definition we are going to use is URL, and apply that to column D. That's actually it. Now, with the click of a single button, I'm going to bring in 6 files at once, and associate a name with them so they don't end up as something awkward like paste entry. I can do more, but in the interest of time, I think I will, move on. I could add group tags, which I'll just do as an experiment from column A, and upload. You do get a pop-up menu to tell you that this is all being done. I'm just going to close that, and you'll now see that I have multiple entries all coming in at once, named by their group name, by their accession number, and are being downloaded via their URL. The tutorial which we are following, the rule upload tutorial, is well worth exploring further. It goes into how to break up URLs if they come as embedded documents, how to identify URLs with distinct forward and reverse reads if you are bringing in paired genomic data, and how to bring all of those in as a collection as well. So I would encourage you to follow along with that one. In this particular case, I now have my 6 entries have come in. It now can see that we have 4,000 lines. They're a FASTQ Sanger GZ file. I can view those and they look like FASTQ files to me. So that's a very quick whirlwind through rule importer. I want to do a shorter version of that to give time for me to talk about one last part of it before I hand over to Simon to talk about some of the other very cool features. So the last thing I would like to show here is that the rule-based importer is really, really great for any style of data, although my personal call on this is that having looked at proteomics data over the years, I think it will be really great for that, where you tend to have a larger number of very small files associated with each sample, and bringing them in en masse by rule-based will be quite helpful. The next thing, however, is your history is going to get large. And I would like to show one quick piece of work on how to manage a history. And by that, I mean the history we have in the background here is roughly 10 items. If you brought in 50 samples, did 50 QCs, 50 trimmings, 50 mappings, then your history is going to grow to many hundreds of items at once. And you may want a way of tracking those through your samples. One of the more powerful ways to track samples is to use the data preview on the right-hand side of your screen. Again, I'm just going to pull this out so you can see it a bit better. And edit dataset tags. Here you can see that we actually do have a tag. It's the group tag we specified on import, but there's no reason, sorry, if I click here, I can't say add hashtag control. It should have populated. Yes, it has. There it is there, hashtag control. To the next one, I could add hashtag sample. Doesn't really matter what they are. You just need to click away and refresh, and that will come back for us. And really the last thing I want to do before I hand over to Simon now is show you that if I run a tool, and since this is Illumina reads that we're looking at here, I'm going to run the FastQ tool to just do a very simple calculation on data sets. And again, since we're skipping you through many things of Galaxy, I can load a single data set, multiple data sets, or collections. I'm going to pick 4, 5, and 6. So something that has 2 different tags and something that has no tags. And I'm going to execute this tool. So I've actually just gone and produced 6 files that are going to effectively clutter up my history. Whilst this is running, we've got a couple of questions, although if the FastQ runs quickly, I'll wait for that. So I'll do both, and then Simon, I'll give it over to you. So the first question, can Galaxy import raw data format from an Illumina machine? Also, can it convert CSVs from Illumina raw data to prep and med formats for Plink? Two good questions. If by raw data, Hilary, you mean any form of FASTQ file, yes. If you mean BCL2 files off, say, a NextSeq style machine, no, I don't believe Galaxy has the conversion format for that, because that's essentially an Illumina image step. I would personally say FASTQ files are the primary data that come off a Illumina machine. So the short answer there is yes. Plink is supported from memory, so yes, there will be conversion formats for doing that. And there is the second question, can we bring data in from Iron Reporter Cloud? You can bring data in from any URL as long as that URL is made publicly discoverable. So depending on how your cloud service operates, so Google Drive, iCloud, BaseSpace, Amazon, if you can make that URL then publicly available, then you will be able to import it into the machine. To clarify with the Illumina format, yes, it does depend on the original format of that file. If it's a CSV file, yes, it'll come in. If it's a particular company-based format, we can bring in ABI1 sequencing traces, for example, but not many people tend to compute against them because generally that raw compute is done before you bring the data into Galaxy. So my 6 FASTQ files have completed here, and simply all I wanted to show you is that those tags of control and sample have propagated through my analysis. So they're embedded on the raw data and on any computed result of that. And I can actually search my history up at the very top button where it says search data sets. And if I type sample and return, my history will now shrink down to just those things that have that tag. And this is an extremely powerful way of tracking a sample type or a cluster of samples, say male versus female, for example, throughout your Galaxy history. So I'd recommend you use tags as well. That is all I'm going to take up on airspace. I will give Simon a go now. I believe I've probably taken up a little bit too much time, and apologies for that.
All right, everybody. Thanks, Gareth. Hopefully you guys got something out of all of that. One of the things that I really want to talk about is a feature of Galaxy called interactive tools. And then the reason for that is when you run a tool in Galaxy, you find the tool you're looking for, you click on the name of the tool, it will open the input data form for that particular tool, you fill it in and you click execute, and then Galaxy will batch-wise send that tool off and calculate results and then display them to you. And it will just usually be displayed in a fairly static manner. However, sometimes you don't really want to run a particular tool, you more want to explore your data, or you may want to play around with your data and just, you know, experiment with your data. And some of the ways you may want to do that are fairly interactive. You may want to use Jupyter Hub, for example. You may want to use Jupyter or a Python notebook or something to, you know, just kind of explore your data and draw some various graphs. Or if you're really good at working with Python, or you may want to work in R and do the same kind of thing. Or you may have a particular data set type, like a metagenomics data set that has a really nice interactive visualization program that you can then load your data up into and manipulate it to produce lovely charts and try and explain some of your data so you can publish it later on. Well, Galaxy has a facility to do that, and they're called interactive tools. Now, interactive tools come in many shapes and sizes. There's, obviously I've talked about some of them already. There's things like RStudio, Jupyter Hub, and when I say that they're available, obviously they are, because You may have used them independently before, but what we've done in Galaxy is we've wrapped them for Galaxy so that you can start them up within the Galaxy ecosystem and talk to all of the files that you've created so far in your Galaxy history from RStudio or from Jupyter Hub or from Finch. Okay, so hopefully that makes a bit of sense. So what I'm going to do now, I'm going to just show you a little bit of a demo about what I'm talking about. If you want to follow along, we didn't talk about importing a history. If you click on Gareth, can you put the link for this into the thing for me? But basically, if I click on this link, it'll open Galaxy Europe up at something that looks like this. And because I'm already logged in, it will just say, here's the history that Simon has produced. That's me, and it's called our demo. And there's a data set in there called iris.csv. I'll zoom in a bit, and I can click on this plus button. For me, I'm going to switch to that history, but for you, it will be, you can import that history into your own workspace. So that means that this is a really cool thing in Galaxy. That means that you can copy my history into your workspace, which is kind of cool. So anyway, I'm just going to switch to this history because it's the one I want to use. And it opens up the Galaxy Europe interface. And it only has one data file in this history. It's called iris.csv. And if I view it, you can see that it's tabular data, and it's got columns of numbers and columns and a column of text. And this happens to just be a very famous data set that's used in a lot of statistics training that somebody collected a long, long time ago. However, this is all well and good, and I'm looking at it, but what I really want to do is I want to load this into R, because I know a lot about R and I want to do some things. So I want to manipulate this data in R. So what I can do is I can search for RStudio. I hope it's done that way. Yep, there it is. And you can see here that RStudio comes up as a tool. That's pretty cool. So I click on RStudio, and yep, we're going to run that. I can say execute. And now I've got a little gray box that says RStudio, but it's queued. Hopefully in a minute it'll go orange. Now, when it goes orange, that means that Galaxy Europe has started up an RStudio for me that I can use. And I'm going to have my fingers crossed that hopefully this goes. All right, so now this RStudio here is working. Now to get access to it, I can't actually just press this view data because that won't work. What I actually need to do is go over to user and say active interactive tools, and click on that. And then you can see here I have RStudio, and it's not quite ready yet, is it? Not quite ready. I may need to refresh it a couple of times. Now what's happening in the background is that Galaxy Europe is starting up a Docker container that has RStudio in it and attaching it to the Galaxy interface. So sometimes this can take a couple of seconds to do. Shouldn't take that long though, I hope. No, it still hasn't gone yet. The job is currently running. All right, so it should be, no, it didn't quite work this time. Let's see if I can get to it now. I tried to do it again. I wonder why I did that. Anyway, fingers crossed. It worked for me about 10 minutes ago, beautifully. Galaxy Europe made us be busy.
Simon, the interactive launcher via visualization is looking the same. Normally that's allows you to select an image, and it's grayed out at the moment.
Yeah, well, it all worked for me about 10 minutes ago, so this is rather annoying. Anyway, what I was going to show you, I may not be able to now. No, it's failed. Why did it fail? I cannot open it. Wonderful. All right, I'm going to have to report this error. So actually, while we're here, if you're using Galaxy and you get a red box like this, if you click on the name, there's a little button down here that says view or report this error. And you can click on that and you can report it to the admins of the server. So I can do that. Click on report and my error report has been sent. And that means the admins will be notified that this tool errored and they can do something about it, hopefully fix it. All right, well, unfortunately, I can't show you this right now. That's really annoying, actually. So instead, I'm going to move on to the next bit. And the next thing I had planned for us to do is workflows. Now, so Gareth kind of showed you how to run some tools and how to upload some data and how to upload a collection of data using the rule-based uploader. Now, you can run some tools in Galaxy. You can say click on a tool form and it will open up for you. You can fill it all in and click the little blue execute button, and you can chain some tools together to produce an analysis by loading all the tool forms in and filling them in and clicking execute again and again and again. And you go, wow, this is a really cool analysis. I really like it. And then you think, actually, I've got another 200 of these to do. I really don't want to go through and click all of those buttons again. So this is where workflows come to the rescue. Galaxy is a workflow engine, which means that we can draw a picture of what a workflow would look like, chaining tools together, and then we can give Galaxy hundreds of data sets at once to run through that particular workflow. So I'm going to show you a demo of that now. So I'll go back to Galaxy Europe. Escape. That's what I needed. I'll go back to Galaxy Europe. I'm going to change my history. I can click on view all histories because I have one already prepared for this. And it is, I have lots of them. As you can see, I have a lot of histories on Galaxy Europe. Here's this one, switch to, all right. So here I have a history, and this particular history, I took in a salmonella genome. It's a FASTA file, and if I click on view data, I can see it, and it's just the complete genome sequence of Salmonella typhimurium LT2, which is a particular nasty kind of Salmonella bacterium, and here is its genome sequence, all 5 megabases of it. Now, I want to understand a little bit about it, so I ran a tool called FASTA statistics on that, and I produced some summary statistics. I looked at its GC content, its length, how many A's and G's and T's and C's there are, how many sequences there were, etc. I also searched in this FASTA file for some antimicrobial resistance markers, and I found that this particular Salmonella is carries the tobramycin and amikacin resistance genes, and so probably don't want to use those antibiotics if one of my patients gets that. I also then ran an annotation tool called Proca because I wanted to go and find where all the genes are, and I produced a GFF file which then told me about all the different genes located in this FASTA file. And because I hate looking at tables of data like this, I then went and produced a nice display of that particular data using Galaxy's internal genome browser called JBrowse. You can see here, you can see here that we have, I can zoom all the way in, And you can see here I've got along the length of the genome, we can see all the genes that are there. And if I zoom all the way in, I can even see all the way down to the reference sequence. There we go. So now I can see the sequence and I can see where the genes are located. And if I click on a gene, it will even tell me about all kinds of stuff. So this is all pretty cool. And I really like this analysis that I've done on my Salmonella. However, I have another history. If I click on this button here, I have another history here that has another 9 Salmonellas in it. This one here. Now, I really don't want to go through and fill in all of those tool forms again for those 9. So what I want to do is I want to build a workflow from the analysis that I've done. And so we can do that in Galaxy. It's really cool. The easiest way to do it is to click on the history option. So I'm really happy with this. History. I like the flow. And so I'm going to click on this history options menu button at the top. And I'm going to say extract workflow. And so Galaxy will then build a workflow based upon the analysis that I did in that history. And you can see here, this is the one I'm talking about. This is the form you get. It says you've used the tool FastA statistics, you used the tool Abricate, you've used the tool Crocker, and you've used the tool JBrowse. And I can say, yep, they're the ones I did. Can you create a workflow for me? And I'm going to call it InCoB2020 Workflow 2. I'm going to call it create workflow. All right, it's done, created. Now I can edit that workflow or I can run it. Well, let's edit it so we can have a look at it. So click on edit and it loads the workflow page. And you can see here that I have some boxes on a screen connected by noodles. And up here is my input. Here are some tools and you can see that this input is going to be run on FastA statistics, Abricate and Crocker, probably in parallel. And then the output of Crocker is going to be sent to JBrowse. All right, cool. We've just created a really cool workflow. So I'm just going to click save. Now I want to be able to run this workflow on all of my other Salmonellas. So I'm going to go change histories to my new Salmonellas. Go back to analyze data. I'm going to go to my history that has all of my other Salmonellas in it, which happens to be this one here. I'll click analyze data again. So now I have a history with 9 Salmonellas in it. And you can see if I click on view data on any of them, I'll get another FastA file. This one happens to be Salmonella enterica Schwarzengrund. And if I click on this one, it is Salmonella enterica Newport. This one is Salmonella enterica paratyphi A. And so I've got a lot of different Salmonellas here. And I want to be able to do the same analysis I did on my other one, on my Typhimurium, on all of these at once. And so the way I do that is I go to the workflow menu at the top of the screen and click on workflows. Now I created one before, I called it InCoB2020 Workflow 2, and I just want to run it. So I'm going to click on the run button over here. And here we go. So it says, I need to input some data here, and here is laid out all the different tools that I'm going to run. But I want to run, it says, oh, you can only run one, or I can select which data set I want to run it on. Oh, I don't really want to do it on one. I want to do it on all of them at once. So if I click on this multiple data sets button, and then click on one, and shift click on the bottom, I'll select all of them. And so now I've selected all of these, and so now I'm going to run all of these on the, I'm going to run this workflow on all of my Salmonellas all at once. So I click run workflow. And here we go. Now this is running 9 times. It's going to create 9 output history. Oh no, it's going to try and do it all into one history. I think. Yep, all into one history, which is why I put the tags on so you can see all the colors. And you can see that it's going through and scheduling all of my jobs. And if we scroll down the history all the way to the bottom, you can see that the ones that are in orange are running. The ones that are green are complete. It's automatically scheduling. It's scheduling a lot of jobs all at once. They're all running in parallel. This is pretty fantastic. So now I've done a really nice analysis. I'm really happy with my first one. And then because my project supervisor is breathing down my neck and saying, quick, hurry up and do all the other analysis, I just load it all into the workflow and click go. And then Galaxy just takes care of it and runs it. So this is a really cool feature of Galaxy. Just the ability to be able to run a workflow on so many data sets all at once and have it track it. And you can see that if I reload this, refresh the history, you can see here that all of the data sets all have color-coded tags on them. So you know which input data file all of these outputs come from. Now, I could have split these out into separate histories and had one history for each of my files if I wanted to, but I just put them all in the same one. It doesn't really matter. And I can do what Gareth said before. I can search here and go NC _ 010102. I probably should do an underscore instead of a bracket. Hit enter. And now I'm only showing the results for that one. And you can see here, the Abracate's already finished running. The fast state statistics has finished running. Procker's doing a lot of work, so it takes quite a while to run. And then once it's finished, it will automatically start running JBrowse. So I hope everyone thought that was pretty cool. I know I always think it's pretty cool when I do it. It's part of my work. I've run workflows that have 50 or 60 steps on. I did it with successfully with 2,000 input data sets. So that's quite a lot of work all at once. I had 2,000 separate input data sets. So they're actually COVID data sets. So I'm going to talk about this later on. And I, in a lightning talk, and I ran a 50-step workflow on those COVID data sets. And Galaxy just scheduled everything. I clicked execute. I came back the next morning and everything was complete. All right. So that's basically workflows and how they work. Oh, sorry. One other thing. If you haven't done an analysis yet and you want to create a workflow from scratch, you can do that too. You just simply go to the workflow menu and say create, and that will give you a blank canvas of which you can add tools onto the canvas and connect them with the little noodles, etc. But that's still pretty cool. Gareth, do you think it's worth trying to do the RStudio thing once more?
Simon, thank you. We are actually at the formal break time. I was wondering if we don't try and upload the interactive environment offline during the break, and if it comes back in 30 minutes, it comes back.
That's probably a good idea.
So if you can either just put up the shared break slide, we may as well just leave it there. The formal workshop afternoon has a 30-minute break now. When we come back, Simon will be leading, and then I will finish off with some complex visualization examples, some more examples of what Galaxy looks like and can look like for you, and then we'll open it up to Q&A. Thank you very much, everyone. See you in 30 minutes.
Dear participant, we will be taking a short break. We will resume the workshop at 3:30 Singapore time. Please try to join back at least 5 to 10 minutes before. After the break, we will continue our workshop. Thank you.
All right, sounds like everyone is online, which is great. Simon, are you going to lead off on the next bit?
I'm just going to check one thing.
Yep.
And then I will.
Yeah.
Just a second.
So I'll just let Simon check what he's checking. Sorry. That's right. From the point of view of galaxies, one of the challenges that we always face is come out in the questions a lot today, that we're all operating our own galaxies and all doing that at various different speeds and various different resourcing. One of the things that's come out this afternoon is not a surprise to us, even if it's slightly disappointing, which is that the interactive tools on Galaxy Europe appears to be currently a little broken. It is one of the most innovative features of Galaxy, and Simon and I have a series of plans to document this service and deploy it within Australia over the next few months. So whilst today it's slightly frustrating, it's actually something that it gives us, I guess, some hope that we're on the right direction about deploying the appropriate resources to build these for everyone. If we can showcase them, we will. If we can't, then as Simon said, you get to see how to put bug requests in, how to look at things that will go wrong in your Galaxy, which is inevitable as you do your analyses, that something, you may configure something wrong or a tool may not be appropriately resourced. Learning how to troubleshoot that is an important part of the service.
Right, just going back to our history from before, you'll notice here that we have all of our input files down the bottom here, and all of our output files, and all of those jobs are completed. And I can have a look at, say, this particular JBrowse instance, and it will load. Waiting. Here it goes. It'll load. And you can see here that if I zoom all the way in, should be able to see our genes. There we go. All the genes for that particular salmonella. So we just did 9 all at once. So I'm going to change histories now to one that I think I've got an RStudio running in. So that one's there. It was running a second ago. Running. So I'm going to click on that. Oh, are you kidding me? All right, so that's not going to work. Bad one. We'll just have to move on from there. Okay. So, Gareth, you were going to talk through, shared histories. You were going to talk through shared histories. He's not here. Okay. I'm not sure where Gareth has gone. Hang on a sec, I'll see if I can find him.
Apologies, folks, I'm back now. Sorry about that. It's Friday night here in Australia, and just picked my daughter up from daycare who needed some off-screen attention. So, Simon, looks like you've covered off the remainder of your workflows inside the workflow section in the interactive tools, and we're up to the circus plots.
Yeah, that's what we're up to. Yeah, unfortunately, the interactive tools didn't go away.
Yep. So yeah, I think we've explained that, and that's okay. So sorry again, everyone, for just being off the screen for a moment. So the last sort of hour we have left, I think it's an hour, is it? Or is it half an hour? Sorry, how long do we have left? I want to show two things. Some of the more advanced plotting features. In this case, it's going to be a circus plot, and also go through some of the other Galaxy instances that exist to, again, give you an understanding of what you can do with a Galaxy, where they are in the world. Yeah, and then we'll go to Q&A. So if you're not aware, one of the plots that we'd like to show you is one of the more fascinating biological plots. I wouldn't call this a genomics plot. It's a visualization tool for mapping against any kind of infrastructure. Traditionally, it has been mapped against chromosomes, but again, it doesn't have to be genetics data. And that plot is a circus plot. We'll be again making use of usegalaxy in Europe, and we're making use of a function called shared histories. If you're not aware of circus plots, there's two things I will ask you to do. You could look up Martin, listed there on your screen, and his fascinating website in Canada. He is the primary author of Circus, and he has given a fantastic 2-hour-long YouTube workshop tutorial hosted by the Australian Biocommons on how to develop, Daddy's talking, on how to do circus plots. We're going to do this at Galaxy Europe. So I am going to share my screen, show you how to find a shared history, how to import it, and then we're going to go through, step through a circus plot and look at how one is developed. So let's head to Galaxy Europe. I will bring up to my main screen, which again, I was just in the same section Simon was looking through at the interactive tools. You don't necessarily need a new history. We are going to navigate to a section of galaxies that's, again, I don't think we've sold up enough yet today, and that is the shared data section of the Galaxy service. There's shared data on all Galaxy instances, except as I think has been reasonably established already today, the data you'll find in a shared data is going to be dependent on that Galaxy service. In this case, we have data libraries. These are files which you may wish to download into your Galaxy history for use and routine use. Typically a data library we would host input files for the Galaxy training network and files related to training that's specific to our country. Histories, shared histories is a really powerful way to publish data that you do have. And shared workflows is the same. If you have a workflow that you think is fantastic, presumably and hopefully peer reviewed, you can talk to your Galaxy admin about making that a shared resource globally. And again, Simon will showcase some of these in his lightning talk on the weekend. Shared visualizations and pages. So we're going to go to shared histories at Galaxy Europe. And probably the first thing you'll notice as I scroll down the screen is there's an awful lot of shared histories by different people at different times and days on very many different topics. We can search under this, and we're going to search for CIRCOS, C-I-R-C-O-S. And even then, you'll find that there are actually multiple plots, multiple histories available. The one I'm particularly interested in showing to you this afternoon is the cancer genomics and chromatopsis plot for looking at breaks and DNA joints in a genome, generally under selection by tumorigenesis or radiotherapy. In terms of the particular history, you can navigate it before bringing it into your collection. You can see here there are 20 odd files. You can also look at community ratings and tags. There's not a good deal of these, and to be fair, that's something I think the global Galaxy community needs to work on. However, Simon and I are both well aware of who this author is and well respect the quality of the work that she does in both running Galaxy Europe and preparing training material. So in my case, take it on faith that I would import this history knowing it's a high quality history, likely to have everything I want. But I have also looked at it prior to this workshop this afternoon. So I can view files in the history, but what I'm particularly want to do is at the top right hand corner, import this history into my Galaxy instance. It comes in with any name, but a fairly logical name, imported and workflow name. Under the hood, you're actually just effectively copying links to this history. So you're not copying all the data, in which case copying a history into your instance is very quick. And here it is here. I have 20 odd files. Well, there are 20 files in the history. There are actually some gaps from file 14 to file 20 is about 5 file gap. And when you get to be experts in Galaxy, you'll note that it does say there are 15 files here and no hidden files. So there has been some work done and deleted, considered unnecessary. What I really want to show you is the power of visualization in Galaxy as a first point. Then we're going to go back and see how this was established. So if we come and look at item number 20, a 1.6 megabyte PNG file, we can view this and it's going to look dramatic and frustrating at the same time. It looks dramatic because there it is on my screen. It looks frustrating because of the auto scaling. It's slightly challenging to see it all in one instance. That I'm not too fussed about because I want to use it as a good excuse to talk to features of Galaxy. For starters, Galaxy Europe has an image converter function, so it can just simply resize the image, and that's something we could do. One of the things I don't believe Simon and I have talked about, we've talked about viewing data, editing attributes. We haven't not deliberately talked about deleting data, but you can certainly delete files out of your history. It's like the analogy would be the Windows recycle bin or the Apple trash bin. You can put them in a delete, but you do need to go through a secondary purge. What I really want to do is download this file, and this will download it, in this case, directly to my home computer into my temporary directory at this point. When I do that, I can open this file at my home computer, and there you can see it in all its glory. A circus plot of the human genome containing, in this case, a male sample due to the presence of the X and Y chromosome, the karyotype with the banding, the P and Q banding, A and B allele for heterozygosity, A and B allele shown again. You get copy number measurements out of the SNP density on the top line, and then you're getting breakpoint information and translocation information shown on the inner circle of the circus plot. So if we count all of that up, we effectively have 1, 2, This is an upper boundary. So 1, 2, 3, 4, 5 separate extensive pieces of information that have been displayed on a single graph. And that is the real power of the circus plots. These can be generated in Galaxy, I would say with relative ease, but some care. And I would just like to step through those without belaboring the points too much. And I have confirmed we've got about an hour and 15 in total left, which means we'll be talking for a bit longer, and then we're going to go into an open Q&A with about 30 minutes to go, unless we run out of things to say before then. So I'm just going to step through some of the file types that are required to make one of these ambitious plots, but really as an exercise in showing you the complexity of what you can do in Galaxy, but also really one of the things I think Simon and I will have succeeded on is if you leave today with a genuine impression of that openness of the platform and the reproducible nature of what you can do on here. So in this case, to a certain degree, and I've talked up Helena's competence, rightly so, but I've taken this history on blind faith. I've brought it in. I would like to know some things about this history, about how it was performed, the tools that were used and the settings that were used. So for starters, I believe that this was shown earlier, there was the extract workflow functionality. I can extract the workflow out of this history. It tells me in this case there were 1, 2, 3, 4 files uploaded. Then a number of things were done to it. There's some selection of data, some cutting of columns, and finally actually not much, but some preparation of circus plots. I'm going to create a workflow just because I'd like to visually understand how this looks for me. That's okay, thank you. Daddy's still on the call. So this is what the workflow looks like on my screen here. I'm going to zoom out a little bit so that it's a bit easier to see the nature of those boxes rather than the actual workflow itself. So there's the inputs, and this is where we were talking about the 2009 features, that one really should go down there. A certain thing was done, selected out of that data type. The selections were piped together here, and finally, in fact, really dramatically, were all piped into single tools on the screen, which is the 2 circus plots as shown here and here. Pardon me for a sec. Okay, so that is the workflow. That gives me an understanding now of what was done to the data. It's not the only way I can explore what has actually happened to the data as I'm analysing it, or in this case, reanalyzing someone else's data. I'm just going to leave this workflow because that was an exploration. And we will look now at repeating, sorry, 2 things. Next one I want to look at is also under this history icon, and there's quite a deal under this history icon that you can make use of. In this case, I know this is not going to be particularly helpful, but I'm going to do it anyway. One of the features that we should always talk up is export tool citations. In this case, what this is going to do is build a biography of every publication that has been cited in a tool entry. So we have 20 different things that happen to this history. A number of them are imports, and imports don't come from a publication in the sense that no tool is invoked. Core functionality that one would expect at command line, like cutting out a column for a file, taking a header, taking a tail, are not referenced. So really what's referenced are primary publications associated with work. Maybe in the Q&A we can look at what this looks like in, say, one of Simon's histories with the Procura and the Abricate, because there'll be a more verbose citation list. In this case, it simply tells you that Martin's primary paper, published in 2009 on circus plots, was the inspiration for the circus tool. and you can go off and read that publication. And this is part of the Galaxy philosophy, to make everything open for you so that you can always go back and establish primary references. If we have students, high degree or undergrad students on the training course today, we always do like to emphasize that if you complete your analysis in Galaxy, this is also a really wonderful way to help write up your thesis, because we generate your reference list for you, at least for the parts associated with Galaxy. So we can do a quick exercise. I'm not going to take too long on this. I simply want to be able to show you what some of the files look like and how we might navigate your way through using Galaxy to explore data. Because ultimately, I think our opinion is that even if it's your data, in most cases, maybe not all cases, you might be using a service provider to produce that data for you, not necessarily in-house. And even if you do it in-house, you're still taking it off a commercial machine and with a commercial machine file format. So getting used to exploring individual data sets is a really important part of doing your work in Galaxy. In this case, and again, I'm not going to go through all these exhaustively. We have a high confidence junction file that seems to make a lot of sense to me, wherever my mouse is currently gone. There it is. A left chromosome and a right chromosome, describing breakpoint junctions in this sample. We have B allele frequency. That's going to look like a nice one. And again, I don't particularly want to look through this file. It's 1.2 million lines long, approximately. And Galaxy, rightly so, has tried to display this. This will be one of those advantages over Excel, where you could well hit a limit. And so this is B allele frequency. If you're not familiar with that, that's fine. It's the minor allele in a heterozygote state. So it generally tends to be a single base position and a value ranging from 0 to 1 or 0 to 2, depending on your scale. So some things were done onto the data, and this is where Galaxy gets really great as that reproducibility platform. I still have 1.2 million lines. It's still in a table, not dissimilar. This table, however, had chromosome start, end, and value. This one looks like it might be very similar, just missing the header, but I don't necessarily know that. And maybe one of the best ways to look at that is to rerun the job. So by clicking on the little rerun function on the bottom of every tool, you bring up the exact tool settings that we used. So this says select lines from file 3 B allele frequency that do not match the pattern something chromosome. Got it, Simon, thank you. We'll cycle back there. This is really important because when you're exploring data, we don't always necessarily know our direct path, and we don't necessarily know the appropriate threshold to put on a particular filtering step or statistical step. This is a very benign tool in the sense there are 3 values, input and 2 settings. If we were doing an EdgeR for differential gene expression or DE-seq2, there may be 20 or 30 values on your screen. If we're doing a circus plot, there could be 50 values on your screen. One of the ways you can make your science absolutely non-reproducible is attempt to type those values out again and again. Any typing is going to lead to potential replication error. The rerun functionality is what makes Galaxy so awesome, because I can just come to any individual line, I can rerun it, and I can simply iterate the one value that I want to change time and time again, knowing that everything else has stayed the same. And this is a super powerful way of looking at your data. So we can understand that particular manipulations were made to our primary 4 files. Further manipulations were made to cut columns out with no value. So cut columns in this case, we do not need columns 1, we needed certain columns replicated, interestingly enough. So 2, 2, 3, 3, 6, 6. So we've cut out and manipulated the data, and ultimately what we're going to end up in is a position where we get one of these wonderful circus plots, which there is 2 in here. We're going to wait for one to load. They're here. We can see all that data on them, from the ideograms to the the copy number inference, B allele frequencies, and then the junctions, the deletions and insertions and junctions. Again, by rerunning, you can see how this is done and you can iterate through this. In this particular case, there's lots of fascinating things happening on my screen. I have a subtle warning that there's a newer version of this tool, and I could come and have a look at the tool versions and understand what offerings that might give me. And I can then also, through that rerun function, work through all the various rules that are available to build my circus plot, including the colors, the backgrounds, if I wanted to insert a background, the radius, etc. I'm not going to step through these in the interest of time now. I would encourage you, when I paste the YouTube link in shortly, to go watch that YouTube link, or head to Martin's website, or head to the Galaxy Training Network. They all have training material on how to use circus plots. So this is really to show you, but A, what these things look like in the end, because they're super cool, and B, how you would utilize a shared history or data library to navigate through it, to understand how you would manipulate your data, how you would then extract a workflow, use that shared history to inspire a workflow, to inspire the similar graphs on your data. Now, Simon has messaged me privately, which is awesome, to say that the interactive tools is working. Is that correct, Simon?
Yes. So I'm not sure if you remember, but before the break, I submitted a bug report to the administrators of Galaxy Europe. Well, they sent me a reply to my email address saying, "Oh, we're very sorry. The network went down between the 2 systems, and they've restored the network, and now it's working again." So.
And I'm going to just question that, Simon. Despite how awesome that is, what time is it in Europe?
It's pretty early, and I'm sure Ian shouldn't be out of bed yet, but he is.
Yes, well, then I doubly appreciate Galaxy Europe's efforts in fixing RStudio for us, given the time of day for them there.
So you can see
yes, sorry, Simon, I was going to say we'll switch back to you, because I think this is a really fascinating part of what we want to hear about.
Yeah. So if you remember, I had this current data set, which looks just like this, and I wanted to do some things in RStudio. So I went to User, Active Interactive Tools, and there's an RStudio running, and I clicked on here, and I have an RStudio. Now you think, oh, that's great, but there's nothing in here. I really, really want to see this iris file in RStudio. Well, note the number here. It's number 2 in the history. So I can go to RStudio server, and I can type in a command, gx for Galaxy _get 2, and it will get the second one. So now it's available for me as a file in the RStudio system as /import/2. Well, that's pretty cool. So I can now go do something like, not sure, let's try iris read.csv, and then /import/2, and hit enter. And so now I have a thing here called iris. So if I type in iris, you can see now I've just uploaded all of that data out of Galaxy into RStudio. All right, and you go, okay, but that's pretty cool, because now I can just do, I'm pretty good at R. Well, actually I'm not, but I like to think I am. I can now play around with it and do all sorts of things. So I'm just going to do a really simple slice out of this table. So I'm going to say that Y is going to be iris, and I'm going to take, let's see, the first 15 rows. Oops. There's 15 rows, and I only want column on 1, and column 4. All right, let's try that. All right, so now I've created a thing called Y. And if you have a look up here, it's 15 observations of 2 variables. It's pretty good. I can see what Y is. There you go. I've just cut that out. You go, oh, that's pretty cool. Well, I'm going to now save this to a file, this Y. So I'm going to go right.table. I'll call it iris out.txt. And I'll maybe say quote equals false. And this is, I want the separator to be a tab. And col, no, I don't really want to include col names equals an A. And I think that'll work. Yep. All right, so now I've written it to iris out.txt, did I? Yep. That should have worked. So now I can send this data back to Galaxy with a gx put command, gx put, and I'll go iris out.txt, enter. Oh, didn't find it. What did I do wrong? Oh. I broke the right table command. That was unbelievable, silly. I need to tell what I want to output.
Simon, we just had a request if you can zoom in a little bit. Is that possible in the Interactive R Studio?
There you go. How's that?
Perfect. Thank you.
So I'm writing out a table of Y. I'm going to call it a file. This is a normal R command. I'll hit enter. So now I've written a file. If I go to see here in the files, there's one called irisout.txt. And now I want to put that back into Galaxy. So I'll go gx_put iris out.txt. Hit enter. Now it pushes it back into Galaxy for me. And then you go, oh, that's great, but what if I want to run this again in the future? Well, I can do gx_save. And it will also save the R workspace as a Galaxy object, which is also pretty cool. So now if I go back to Galaxy, you can see here that iris out is being uploaded, and pretty soon workspace.r data and workspace.r history will be uploaded back into Galaxy. So if I click on view data here, there it is. That was the data that we produced inside R. So we went from this data, we exported it to R, we played around with it. You know, we decided to do some bespoke analysis, you know, weirdness, and play around with it and just experiment with our data. And we go, actually, this is pretty cool. I want to import it back into Galaxy again. And so we did, and here it is. And the cool part is that we've saved our R history and our R data. So if I click on this, we should see what the R history is. There's our R history. So there you go. Pretty cool, huh? And now I've finished using RStudio, I'll go back to Active Interactive Tools and say, all right, you can stop that one. Thanks. And it gets blown away.
But importantly, the workspace data and history is contained should you want to understand and repeat that work again, right, Simon?
Yes, yeah. So click on this, you should just be able to go no, not that way. I can't remember how to do it, but off the top of my head,
That's all right.
I easily look it up.
Yep. No, that's absolutely fine. That's the point being that it is there if you need it. I am just pulling up on my screen something related to the interactive tools. I'm just waiting, perfect. So that's really cool. And I stayed quiet through all that because it's actually something that I need to know a lot more about, and it's quite fascinating. What is available on Galaxy Europe and what we're advocating to be available across the Use Galaxy servers with time is more than RStudio. So the offerings at Galaxy Europe can be found at live.usegalaxy.eu, which again, I'll just post into the Discord link. So Jupyter, RStudio that Simon's just showed, some very cool BAM and VCF IO files for visualization of those two data types. Finch is a great one for large microbiome data sets, and it gets used in the Galaxy training network. And some important different ones, I guess. High Glass, which is for viewing of high C or chromatin configuration infrastructure data, and some species ones, which I think are very cool, given that what we're about to talk about are some of the other galaxies that exist for doing different pieces of work. And a calculator, and somewhere in here is a command line or a virtual desktop environment. So the interactive tools really do offer a huge amount of flexibility. In some ways, that flexibility contradicts with the lovely reproducible nature of Galaxy, but that's why it's so great to see in Simon's history that those elements of RStudio that allow you to repeat that work, or at least audit that work, are brought back and captured into your Galaxy history alongside the files you manipulated. So thank you for that, Simon. That's really cool to see, actually. So I want to then tail that into a few slides I'm really just going to talk at, and I think we might get into the Q&A 5 or 10 minutes earlier than planned. So do have your questions ready. We're ready. So one of the challenges of all the global galaxies is how to maintain relevance to a particular community of practice, a particular community of scientists. We've talked about the public Galaxy servers, and when you go and explore those, you'll see they're very much aligned with communities. So there's a Galaxy for the International Rice Genome Consortium, where the tools that are on there and the information that's on there is highly tailored to that genome, for example. The Galaxy Europe has done something which, again, we're planning to do in Australia with time, but I think it's a fascinating version of their instance. So you can go to subdomains of their service. In this case, I've shown single-cell.usegalaxy.eu. And this is behind the scenes, that exact same infrastructure, for the, or at least the European equivalent of what Simon showed early on in the workshop for the Australian infrastructure. It's just simply a different landing page to the same information with a cut down set of tools relevant to single cell, and a landing page relevant to that community with training, workshop, tutorials relevant to the analysis of single cell data. Nothing else under the hood necessarily changes, or at least nothing worth drilling into right here. But the whole idea is that if you have a community of practice, those people doing single cell gene expression or variant calling, now have a place to come to where the tools are tuned for them and the information content is tuned for them. So again, if you're thinking about running a Galaxy, or if you're thinking about your local communities of practice at all your various institutes, you may want to consider tailoring a Galaxy for that. So we've got the big usegalaxy.stars with thousands of tools that are trying to cover everything. It is actually okay in that sense to have a dedicated landing page with a sub-community. So the single cell one, again, doesn't take us too far from our core business of genomics inside life science. The High-C Explorer takes us, I would say, a little bit further away as quite a fascinating new technology for mapping chromosome level information. But again, this it was at usegalaxy, and again, it's a subset of those tools devoted towards exploring high-C data. And here's one that's a little bit novel, and unfortunately is only a screen grab, so you can't see this nice animated bird chirping back and forth. This is the ecology version of usegalaxy. This one is inspired mainly out of France, and it has a whole heap of tools dedicated to species tracking and ecology, and very, very different workshops, tutorials and data styles associated with ecology that you know, may not well fit into the format that's on your main galaxy, but is ideal for a subdomain of galaxy. Two more that I want to talk up as part of wrapping up for this afternoon. And this one's really taking a leap in a different direction, and this is galaxyp.org. So the Galaxy P platform, it has a lot of subdomains. Shown here on the right is their metaproteomics division. However, their overall vision is to provide a Galaxy instance that champions metaomics studies. So the combining of genomics, transcriptomics, metabolomics, and proteomics data. So they actually have subdomains as listed on the left-hand side of the screen there for proteogenomics, metaproteomics, and they do have a mirror at Galaxy Europe. But if you are interested, their latest multi-omics visualization tool has been released in the 2009 update of Galaxy, but you can go and use their features at Galaxy P for really looking at a very fascinating way of visualizing multiple data types. And as Simon and I have both alluded and gratuitously plugged in the last few hours, this is not our only presence at the InCoB conference this year. We're thrilled to be doing anything. We're getting to do two different things. So this coming Sunday, in Singaporean time at 1:47, Simon will be presenting a lightning talk on the role of Galaxy Australia in the global response to COVID-19. I won't steal all his thunder for that, other than to say that there is a paper, and in the reference to what we're talking about, which is unique Galaxy instances, there is COVID-19 at galaxyproject.org, which will take you through multiple opportunities for looking at how to analyze the genome of COVID-19, understand the evolution, the chemoinformatics, the proteomics, some of the amplicon-based data, and direct RNA sequencing. So I've already probably said more than I should about Simon's talk. He's going to talk in more detail. But this is a fantastic opportunity to really highlight our Galaxy that came about very quickly in response to the COVID global pandemic. So that's it. We have finished a little early. Apologies. We went from, I think, feeling like we're out of time to being a little ahead of time at the end. We do have lots of time for Q&A, and I'd be particularly interested if anyone would like Simon and I to demonstrate any of the features of Galaxy we got to gloss over. We can do any live demonstrations or answer questions. In conclusion, though, we need to thank the entire Galaxy Australia team is listed here. It's not just Simon and myself, it's Igor, Tom, Nick, Catherine, Ewan, and Michael. And our funding partners, primarily the Australian Biocommons, our primary institutes, QSIF and Melbourne Bioinformatics, and all our underlying infrastructure support we get around Australia and globally. So that's the formal part of the workshop concluded. We are here for questions.
And you can either ask us directly or you can type them into the chat or the Discord, and we're more than happy to answer any questions you may have.
Thank you. We do already have one from Hilia, who's doing great, asking lots of questions. Does Galaxy A have complete platform for complete GWAS pipelines? And that's a really good question. I'm going to answer it, Hilia, in two different ways. One is a technical way. So ask as many questions as you want. Under the hood, Galaxy is as powerful as any of the computational resources you can link it to. So traditionally that would be virtual machines on a cloud infrastructure or what you call bare metal machines at your institute. We're really excited actually for multiple things. Next week, as I said before, Simon and I are going to have some formal discussions with one of our national compute infrastructures to look at getting a large amount of resources there, but we're also buying GPUs and high memory nodes to allow us to start computing newer styles of data styles that we traditionally in Australia haven't done before, like long read sequencing technologies, nanopore and PacBio, extensive memory intensive analyses like metagenomics. So there's actually no reason in that sense we couldn't do GWAS, given it is actually quite memory and CPU intensive. What I don't know is, do we have an end-to-end tutorial set up? And in the short answer is I can't find one, but that doesn't mean there isn't a good excuse to create one, is the other half of the answer. The next two questions are, is it freely accessible? And the short answer is yes. If you go to Galaxy Project and galaxyproject.org use and you search on your public servers, you will find those ones that are freely accessible. The majority of Galaxy instances do triage the amount of work you can do based on your location. So in Australia, not to sound terribly rude, we give a larger amount of analysis space to Australian researchers. If you come from an identified educational domain, we still give you a large amount. If you come from an unidentified commercial email address, we give you slightly less. So that would be the difference between a .edu account and a .com account. So we're now looking at the galaxyproject.org, and there are the Use Galaxy resources listed clearly at the top, and all public servers are listed here, and many of these you will see have a subdomain style of work to them. Did I cover that one enough, Simon?
Yes, that's fine. Can I share my screen to answer this?
You can. We're getting lots of questions, so this is awesome.
Share. Okay. So the next question was, I'm going to bring the chat back up again, it disappeared. Why did it do that? There we go, chat. Okay. The next question is, as a very beginner, which self-learning tutorials would you recommend? And that's highly dependent on what you're trying to learn. If you're trying to learn how to use Galaxy, then if you go to this website, which is obviously a little bit, training.galaxyproject.org. It'll take you to this website here. And as you can see, this website says, welcome to Galaxy Training. And there's this one here that says Introduction to Galaxy Analyses. And if you click on that, there are 10 different tutorials. And some of them have ratings. This one here, a short introduction to Galaxy. It's probably a good one. It has a video. It has some slides to look at. It has hands-on, has some input data. It has a workflow associated with it. So that you can click on the slides and it will show you some slides. So you can click through these. You can see what is Galaxy, why do you want to use it, how are you going to use it, how you upload data, what the history is. And you can see it's got some nice animations in there so you can see the different aspects of it. So these are all pretty good walk through yourself kind of things. And then there's a hands-on section. So if you click on that, it will take you to a walkthrough tutorial. And as you scroll through it, there are these little blue boxes that are hands-on. And this one says, log into Galaxy. And this is how you log into Galaxy. This one uses Galaxy Australia. And then the next section, you scroll to more. The next section says, oh, how do you change the name of your history? And so it actually walks you through all the different steps of how to get into Galaxy. And you think, oh, that's great, but I kind of know how to use Galaxy. What I really want to know is I want to know how to do RNA-seq differential analysis. So I can scroll down to transcriptomics, which is a topic, Click on that, and you can see here that there are a number of tutorials on all sorts of different things. There's some for 10 single cells, some for metatranscriptomics. There's an introductory slide deck for it. There's de novo transcriptome reconstruction with RNA-seq, so transcriptome assembly. Yeah, so there are a lot of things here. There are also, we are currently working on suggestions. And so if you get stuck and you're at this website and you go, oh, don't really know where to start, down here where it says open chat, click on that. It will open a link to our Gareth page, and you can, actually you have to sign in, but once you sign in, you can start asking questions in here, and one of the many people in the Galaxy community will answer your question and try and help you out. So I hope that answers that question.
Thank you, Simon. I think that does.
Can I answer the next one as well?
You want to do Caleb's question? Is that the one?
Yeah. So Caleb.
Yeah, please. Yep.
So Caleb from working in Kenya at ICIPE Nairobi, Kenya. We are just starting to set up Galaxy for local use. We only need to set up tools that are needed for our kind of research. Is it possible to get access to configurations to select tools? Yes, it is. I'll just do a super quick demo of that. I am the administrator of Galaxy Australia. You need to be the administrator of the Galaxy server to install a tool. I am the administrator of Galaxy Australia, so this is Galaxy Australia here. I can log into the, you'll see up here I have an admin thing. I can click on admin, so it will load the admin page, and I can say tool management, install and uninstall. Now I can search for a particular tool that I may want, and let's do Spades, for example, which is a genome assembler. I can click on Spades, and it says here that we have a whole bunch of different revisions. Any of them that I want to install, I can just click on that button there, install, and it will install that particular tool for my Galaxy server. But I'm the administrator of it, so I'm allowed to do it. So Caleb, if you're the administrator of your Galaxy server in Kenya, you can do exactly what I just did. Look for the tool you're interested in and click the install button, and it will install. Okay. Does that answer your question, Caleb? Yeah.
Does look like that answered that one, Simon. Thank you. And I'm glad you did. I had a different take on the question, but it looks like you answered it in the way that it was going to be answered. So that's great. So we've got an explorative question, actually, which comes back to the GWAS one. And I'm more than willing to take a shot at this one. Please do keep your questions coming if you have more. So the question is around, can I give a short demo or link for a recommended GWAS pipeline in Galaxy? And this is actually a really nice, humble way to say, actually, I don't know myself a great deal about GWAS studies. I know them at a principle level, but not at a tool level. And this is, I'm going to give a two-part answer. So one part is one of the challenges of running a Galaxy service with 1,200 tools is that it's very difficult for any of us individually to be experts in 1,200 tools. And it's definitely nigh on impossible for us to be an expert in the other 5,800 odd tools we haven't installed from the Galaxy toolshed. So the short answer is no, I don't know of a pipeline for GWAS in Galaxy, but what I do know is how to Google. And that sounds very flippant, but the whole point of this is that that Galaxy community is about 15 years old now. There are over 10,000 online publications associated with Galaxy. So a simple search for GWAS in Galaxy will start to bring up a number of places. Peer-reviewed publications in NCBI, there's an Excellence in Breeding Galaxy service, there's an EBI one on this list. Anvil is another Galaxy service, actually, I didn't see that one. So the idea here would then be to come and actually critique these publications, have this open on your secondary screen and see how much of it you can actually replicate inside your own galaxy. Now, this particular paper is a few years old, so that might pose a challenge for some of the tools. However, the EBI one does seem to have at least a little bit more clearer format on use of HapMat, of filtering of data, the style of workflow that you're going to need to apply. You could then take inspiration from this. Then you would go to the toolshed and look for the things that were potentially missing on the Galaxy instance you were on. So yes, it is going to be a journey for you. I think I will spend a couple of minutes in a sec showing you more about how to build a workflow because they are very powerful, but understanding how to troubleshoot them and how to fill the gaps in them is also particularly interesting. So the short answer of that is I've given you the complete politician answer of I can't answer your question, so I'm going to talk for a long time, and apologies for that. But the point of it is that please do take inspiration from all public resources on discovering a new area. I think if anything, GWAS has been underrepresented on Galaxy because it tends to be quite memory intensive, and I believe that is changing. Well, it's certainly changing with the three major use Galaxy servers on the amount of resources they have to support them. So, Simon, did we show blank canvases that much or not?
No, not yet. I mean, I talked about it and we showed the canvas, but we didn't show the blank one.
Pardon me, great. So very quickly for those that are still here, which is quite a few actually, under workflows, you can extract a workflow out of the history, you can import a workflow, you can share a workflow. But if you're feeling a little like an artist, you can be presented with a complete blank canvas and utilize that blank canvas to build a journey through your data. So I have just invoked what's called an empty canvas. You can zoom out, you've got a navigation box, and I'll just show you very high level how a workflow works. So the first thing you generally need to do with a workflow is specify an input. The input will come into your screen as very bland. It's an input data set, and its only function is to have something come out of it because it's an input for other things. Then you have a tool. This is one of my favorite workflows, so you're going to see me create this again and again, which is the FastQC tool. Sorry. Here on my screen, this is a tool for QCing data. I can pipe my output from my input into that tool. If it's acceptable, the line goes green. Once they're connected, that relationship is in place. I can break the relationship by the negative symbol and do it again. We have more questions, so I'm not going to take too long on this section because I want to get to your questions. I'll just wait for my second tool to load, which is Trimmomatic, a tool for selecting high and low quality reads. Importantly, you can oversample an input. So I can take my input, I can specify it to go into Trimmomatic, and then I can then do things with these outputs. I know I can take the output of Trimmomatic and pipe it into FastQC, but I cannot pipe it into where there's a connection already made. That breaks the logic. That's how workflows are created, an understanding of what you want to do to your data. Inside the workflow, you do not have a history menu on the right-hand side. You have a tool configuration menu. You can set all your tool settings as you make your workflow, and then they will just be used time and time again, and that's what gives that reproducibility to the service. Given we have some questions, I'll leave this up on my screen and we will answer the next two questions and come back to this if needed. So from Rizana, apologies, oh no, sorry, Keek here, yes, sorry. If we use different Galaxy server to do microbiome analysis, will the reference data set be different? Well, there's a really good question, actually. I'm tempted to say how long is a piece of string, but it is not that. If you use a sorry, you go for it, Simon.
Sorry, I'll be happy to answer this one because
yeah, go for it.
So if you use one of the large public servers like Galaxy Europe or Galaxy Australia or any of the newer ones that are starting to come online, part of the usegalaxy.star network, we all share reference data, which means that if you do an analysis on Galaxy Europe using, say, I don't know, the Green Genes database, for example, or Kraken2 or whatever you're doing it on, if you then run it in Australia, you will get the same reference data because we share our reference data. However, if you run it on a smaller, or it's not smaller, but if you run it on a different Galaxy server that doesn't use our shared reference data, then hopefully they would have specified the version and the provenance of that reference data. So what we try and do on all of our servers is specify the provenance of the reference data that we're using. So if it's Green Genes, the exact version of the database that we're using, or if it's Kraken, the build number and the date that we got it, etc. And so all of those are listed. As long as those numbers are the same, then yes. If the particular version you need isn't available on the Galaxy server that you're using, you just need to contact their administrator and they can load that for you fairly easily. Hopefully that answers your question.
Yes, that's, I think, a perfect answer, Simon. I'm only going to go 5% further and take a different view of that as well, which is if you have done something in Galaxy, pardon me, that you're quite fond of, then saving the manipulation of your data as a workflow will capture all the tool versions that we utilized, not necessarily the database versions, but the tool versions that we utilized. This does mean that you can return to an analysis 6 months down the line, and if the Galaxy instance has updated a tool to a newer version, that will be the tool present in the left-hand menu of the screen. If you load your process in through a workflow, you will get warnings that tool versions have changed, and this gives you an opportunity to audit and explore the tool versions and why there might be consequences, if any, on your data. So I'd always encourage you, even for like what's still on my screen there, an extremely bland two-step workflow, saving that as a workflow will capture for me tool versions and provenance of tool versions historically in a way that running it time and time again just by selecting the tool will not. So yes, we do as a service, all the Galaxies try to give you that longevity of insurance as well. Simon, I was wondering if you wanted to take Justin's question, if you may, about RStudios.
Next one in line was Hilliers, and that was about tools.
So, oh, yep. Oh, sorry. Yep.
Yep. Can I just have the thing for a second?
Yep.
So, share my screen. Okay. So, yes, here we go. The answer is if there's a tool missing, so there's a tool that Galaxy doesn't have available yet that you need for your pipeline, and it hasn't been put into any Galaxies yet, or it may just not be available on your Galaxy yet, then you can get it added. However, if it doesn't exist in the Galaxy App Store, the tool shed, then we have a process whereby the Galaxy community can build that tool for Galaxy. And so there is a GitHub repository, which I'll put into the chat soon, github.com, and it is Galaxy project tools-IUC. And basically, this is a GitHub repo, just like any other GitHub repository. But this one is specifically for wrapping Galaxy tools or getting tools into Galaxy. And there's a community of about 150 to 200 people globally that put tools into Singularity and into Bioconda and to other things. But they also, a lot of them also put tools into Galaxy. if there's one particular that you would like to see, if you go to the issues page here, you can search for the particular tool that you're looking for, and if you can find that tool, the issue, say, yes, please, I would really like this tool. If it doesn't exist, create a new issue and ask for a tool to be included. And that's the best way. And then the global Galaxy community will see it, and then maybe someone will volunteer their time and start working on it. But if you're interested in doing it yourself, then if you go back to the training material website, there's training on how to do that as well. Does that answer your question, Julia?
Yeah, thank you so much.
Oh, awesome.
Simon, did you want to just, before you move on to the next question, and sorry, I'm making you answer all of these, just explain the concept of, I guess, licensed software and its relationship to Galaxy?
Yeah. So Galaxy is a completely open source project, and which means we're happy to give it away to anyone who wants it, and anyone can download it, anyone can modify it, etc., etc. If you are running a Galaxy server and it's available to the public, then you need to be kind of careful about what tools you put on it. You need to only put tools that are licensed to be run by the public or anybody. So on our server, for example, because it's open to anyone who wants to use it, we actually can't put on commercial software onto it. So we can't put on proprietary software or any software that comes with a license saying that each user must pay to use this software, because well, we don't have the budget to pay for every user on our system. We have 10,000 users. We don't have the budget to pay for everyone to use the software. And obviously we're breaking the license agreement if we give it away for free. So sometimes you may just need to be a little bit careful about the license agreement of the software that you intend to put onto Galaxy, if that makes sense. However, if you're running it internally in your lab and your lab has a license for that particular software, then that's fine, as long as you don't make it available to everybody.
And it does also mean, rather brutally, if you ask the community or us to put on a software that comes with a license agreement, the answer will almost always be no. So that's not supposed to sound super negative. That's just to acknowledge all the things that Simon just described.
And then Justin's asked the question, can we integrate an R script or Python script into a workflow without using RStudio or an IDE as an active interactive tool? So yes, you can. However, what you need to do is turn that R script into a Galaxy tool. So we have a perfect example of that. We had some researchers in Queensland where Gareth works, and they wrote some R scripts that were really good for manipulating their particular data for metagenomics. And they said, we would really like to have this in our pipeline. Can you please make it so we can use it? So within, well, actually, it's quite simple to do. If the R script's not too complicated, doesn't have too many dependencies, it's very simple. If it's a little bit more complicated and has lots of dependencies, then it could take about a week. But we have a bioinformatician who works for Gareth up in Queensland, and he imported 5 or 6 of these R scripts into Galaxy and then made them available to the broader community for everyone to use. And that took him a couple of weeks to do for all 5 of them. So it wasn't too long. And now they're available in anyone's pipeline. So we can't just let you type in an R script and have it become part of a workflow, because then we're kind of making a public service run arbitrary code. And that's a real security issue. And so what we really need to do is, if you want to have an R script or something like that run within Galaxy, then you need to build it as a tool properly, and so that you really restricted it what it can do, and you're not just running code that anybody's typed in, if that makes sense, because that can be really dangerous in an open computing platform. Does that answer your question, Justin?
Yeah, thank you. They're an amazing series of questions, so we really appreciate that we're getting some complex answers to this. Also, I would say, to a certain degree, that's the inspiration behind the interactive environments or the interactive tools. How we build those tools into workflows, we're still learning as well. So yes, there's a lot going on in this space. So we can, we've still got a few extra minutes. I have just checked the spreadsheet. Not everyone, I think, has populated it with their details. If you would like a copy of the presentation that Simon and I have done, please do fill in the Google Sheet that was put up slightly earlier, and we can send out a copy of the slides as a PDF for you. Otherwise, we still do have one. Oh no, sorry, Simon, you just answered a question. That was one more question. Otherwise, I think we can stay online for a few more minutes for sure to answer some more questions.
Luckily for us, the organisers here have assured us that they can take the chat log and they can put it into the what is it? I can't remember what it's called. Discord server.
Mm-hmm.
It's getting late here in Melbourne now.
Yes.
Into the Discord server, so that it can be, you can go back and look at it and then click on the links, etc. later on.
That's true as well. Yep.
Okay. If anyone else has any other questions, we're happy to hang around for a little bit longer if you like. Otherwise, thank you very much for your attendance, and we hope you all learned something and got something out of today. So yeah, thank you.
Photo session.
Yeah, before we end this session, I will invite you all to have a photo session. You can open your video now. But Simon, can you stop the share screen so I can?
Simon, can you oh yeah, I think we'll both just
Okay,
say
thank you.
Hello, everyone.
Anyone want to open the video?
Sorry, I can't open my video.
Okay, it's okay. Okay, so it is the end of the session of Galaxy Workshop. Thank you for joining us in InCoB2020 for all participants. So thank you for Dr. Gareth Price and Simon Gladman for giving the very interesting workshop here.
Our pleasure. Thank you very much.
Yeah, thanks for having us. It's always nice to. Well, I can talk about Galaxy for days if you let me, so it's fine.